In this question, it asks us to find out the electric field due to the dipole on point P. I've already made a diagram here. This is going to be our x. This is going to be total distance d. This is our dipole and this is point P. Let's consider this as, suppose, A. Now we know that the electric field due to the point charge is equal to k constants times q, that is our charge, divided by r square. We also know that our E1 is going to be kq by r square. Also E2 is going to be equal to kq by r square. Now since we are going to involve the x components, we need to find out what our cos of our angle theta is going to be. Now since this is equals to theta, this is also going to be equal to theta. So using some people curly brown here. Okay, base divided by hypotenuse, we get our cos theta is equals to x by r, which is gonna be small r square plus a square root under. This is using the Pythagoras theorem. Now we need to find out the net electric field at the point P. Now our net E will be equal to E1 plus E2, meaning that these are in the x components only. So this is gonna be E1 cos of the theta plus E2 cos of theta. We have already found out what is our E1 cos theta and E2 cos theta, so we'll just, I bet this is going to be r square. So we just need to plug in the values we got. So it's going to be square plus a square times square plus a square plus kq. So basically this is just multiplying by 2 because it is just the same. It is the same thing. So we can say this is 2kq. Now for x, we know that x is the half of the distance of d, so we can just plug this as d by 2 divided by d by 2 square plus a square whole power 3 by 2, and our answer is just kqd by d by 2 square plus a square 3 by 2. Now this is our expression for finding out the electric field due to the dipole. Now our other side of the question is asking us to find what is the force on charge due to the dipole. Now force on charge due to the dipole is given by E times Q. Now we can find E by plugging in the numbers given in our question, and by doing that we get the value of 575.65 newtons per coulombs. Now we just need to put this value in our equation of EQ, where E is 575 times 65 newtons per coulomb, and our Q is also given 2 times 10 to the power minus 9 coulombs. So that's going to be 1.15 into 10 to the power minus 6 newtons. Now to find the electric force between the point charges, we just need to use our equation of force between the two charges, that is k times q1 q2 by r square, and just plugging in the values we'll get our answers. And we need to compare the result. I have made the calculation here, and our force is gonna be 2.88 times 10 to the power minus 5 newtons. So force due to the point is greater than the dipole that we got. Hence using this we can find the electric force and also the um, and also the force on charge due to the dipole.